Tree students, in this lesson we are going to be learning about triangles. We're going to be talking about some theorems related to what triangles are and the relationships between the angles inside triangles. The first theorem is an obvious one for anybody who's worked with triangles for any period of time. The sum of the measures of the angles in a triangle equals 180 degrees, or the measure of angle A plus the measure of angle B plus the measure of angle C equals 180 degrees. Now, this is a theorem that we know, but we often take for granted. I wonder if there's a way for us to prove this. So here I have a blow up of that triangle ABC. And actually, let's blow it up 3 times. ABC, ABC, ABC. Okay, so I'm going to take this larger triangle ABC, and I'm actually just going to look at one angle at a time. In this one, let's take a look at angle C. In this one, let's take a look at angle A. And in this one, let's take a look at angle B. Okay, so you see I have this triangle ABC up here, and down here I have each of the angles in triangle ABC. What happens if I flip this angle over and I join these 3 angles at a common vertex? Okay, so I'm going to join these 2 together, and then I'm going to take this third angle of triangle ABC. This would be angle B, and I'm going to join together so they all 3 have a common vertex. Well, would you look at that? This works for any triangle, by the way. If you put all 3 angles in a triangle together at a common vertex like this, you're going to have to flip one of them over like I did. But when you do that, you get a set of linear angles. Okay, it's not a linear pair. Here's a set of 3 linear angles. And when I add together 3 linear angles, what degree measure do they have to add to? 180 degrees. So this is just a visual proof of Theorem 18.1. Now, the next thing we're going to talk about is some corollaries to Theorem 18.1. What is a corollary? This is the first time we're talking about a corollary to a theorem. It's a statement based on a theorem that logically follows directly from that theorem. And we're going to look at a few corollaries to Theorem 18.1. So the first one, corollary 18.1.1, if two angles of one triangle are congruent to 2 angles of another triangle, well, let's think about that for a second. If 2 angles of a triangle have certain measures, that really locks in what the third angle has to be. Because if angle 1 and angle 2 add up to, say, 100 degrees, angle 3 has to be 80 degrees. There's only one angle measure that'll cause it to equal 180. So that means if we have 2 different triangles and 2 angles of one triangle are congruent to 2 angles of the other, the third angle also has to be congruent because we're forcing it to take on that last value. Okay, does that make sense? Let's move on to corollary 18.1.2. The acute angles of a right triangle are complementary. Okay, let's think about this. A right triangle has 1 right angle and 2 acute angles. The right angle takes up 90 degrees of 180. That means that the remaining 2 angles have to equal the other 90 degrees. They have to be complementary to one another. All right, let's take a look at corollary 18.1.3. The measure of each angle in an equiangular triangle is 60 degrees. Well, okay, let's think, if it's equiangular, that means we're splitting the 180 degrees among 3 angles equally. That's where 60 comes from. And then lastly, corollary 18.1.4. A triangle can have at most 1 right or 1 obtuse angle. And the reason is because there's 2 additional angles, and we have to split the rest of the degrees between 2 angles. If a triangle has a right angle, 90 degrees, it can't have another right angle because that other right angle would take up 90 degrees, and then there wouldn't be any degrees left for the third angle. So because we have to split the remaining degrees, after we have an angle defined, we have to split the remaining degrees among 2 other angles. One of those angles can't be 90 degrees or greater because then we wouldn't have enough degrees for the third angle. All right, then just one more theorem, and this is practically a corollary itself. The measure of each exterior angle of a triangle is equal to the sum of the measures of its two remote interior angles. By the way, what is a remote interior angle? It's the angle inside the triangle that's away from where the exterior is. So for this exterior, I'm talking about angle C. My exterior angle is going to be built on angle C of the triangle, okay? My remote interior angles are not going to use angle C. It would be angle A and angle B. I have to be on this side of the triangle. Let's think about this for a second. If angle D is an exterior angle, that means that angle C is going to form a linear pair with angle D. Your exterior angles are always a continuation of one of the sides of your triangle, and they always form linear pairs with the side that they're a continuation of. All right, so it forms a linear pair. What does that mean? Well, that means that ACD is supplemental to BCA. Okay, let's think about that for a second. BCA is going to take up a certain angle measure of my 180 degrees. The other two angles have to add up to, when I add it to like BCA, they have to add up to 180 degrees between the two of them. But ACD is also supplemental to BCA. So when I add those two angles together, they have to add up to 180 degrees as well. So it's just that because this is supplemental and these two have to add up with angle C to 180 degrees, a supplemental angle has to add up with angle C to 180 degrees. That's the relationship. Because both have to add up to 180 degrees, that's why this has to equal the sum of these. Because when we add it to angle C, in both cases, they have to add up to 180. All right, we're ready to work some practice problems related to these theorems and corollaries. We'll do that in the next video.